I think that software quality has improved, particularly over the last 4 or 5 years. And I think that's mainly due because of increased automation. There's been a lot of attention on code coverage, increasing code coverage. So I think that's made some good progress. At the same time, I think what's stressing quality of software is the speed. If you look over the last 4 or 5 years, as companies move to CI/CD, they're increasing the velocity of software delivery. And when you do that, unfortunately, oftentimes quality does get sacrificed. So what's the alternative? The alternative is we don't ship fast. Well, the problem with that is there's this thing called competition, and there's a lot of them, right? If you look at 2012 alone, there were 3 software companies in a particular category. 6 years later, in 2018, that number jumped to 9. And today there are 11. 11 competitors in each software segment. So you can't stand still. I mean, when is the last time your head of engineering or your manager said, hey, let's slow down the build? Never, right? Because of increased competition and this desire to be able to remain competitive. In this world, there's so many different alternatives and functions. You have to move fast. You have to iterate fast. But at the same time, sometimes that comes at the expense of quality. So what do? Well, you have to mitigate and you have to try to accomplish both. But it's not easy. And I'll tell you, when software quality does get diminished, it comes at a significant cost. 40% of developers will say, because they're moving fast, that's what's leading to errors. 60% of developers will tell you they're spending their time not developing new features or new functions, but just maintaining and troubleshooting existing code. Not doing a lot in innovation there. Last year, there were $3 trillion worth of software defects in the United States alone because of software errors, critical software errors. So you see it comes at a cost. Right? So what are companies doing about it? Well, certainly they're making large investments in people, processes, and technology. But despite all that, despite all those investments in people, process, and technology, what's still happening is this insufficient, frustrating loop to resolve issues. Now, let me share what I mean by that. When an issue occurs, how do you know about it? Well, typically you get a phone call or an alert from your customer, right? Because it happened out in the wild. What you then try to do is you work your hardest to try to recreate that defect path. You ask the customer for logs. You look at them. They don't have all the context you need. You ask them to increase the verbosity of the log. They're hesitant to do so. Or perhaps they're concerned about redaction. Sometimes you get a log, sometimes you don't. You open up the log, it doesn't have all the context that you need. You huddle with your engineering teams and you look for ideas. Some people may say, let's recreate a build that we can use as a debugger. And they attempt again. And this could go on for hours, days, weeks. And many times the issue can never be reproduced. Why is that? Well, it's because you don't have the full context necessary to resolve that issue, no matter how much logging you do, no matter how much performance management you do. No matter how much testing you do ahead of time, you cannot anticipate the millions of permutations that are going to go wrong when you release code into production. So you can see it's a quandary, right? What organizations are trying to do is find the balance between the two. What they really want to do is have the ability to have continuous reliability from pre-prod all the way through to production. And when an issue does occur, they want to be able to resolve it before the customer is ever impacted. So what's the state of the software quality in the world today? I think it's improving. There are some pressures because of the velocity of releases, and I don't think that's going away anytime soon.